Hello, and welcome to Tech Connects, Dice's podcast where we dig into the topics on tech hiring, recruiting, and careers that matter to you. I'm your host, Nick Kolakowski, and I'm going to talk to great guests every month about the current state of the tech careers world, including the tech job market, the hottest tech skills, what companies are doing to attract and retain technologists in a historically tight market, and much, much more. Our guest today is Kaitlyn Albertoli, who's CEO and co-founder of Buzz Solutions, which uses predictive analytics, AI, and other cutting-edge technologies to inspect and evaluate the power grid. This is critical work, as power companies need this kind of data for everything from anticipating power outages to ensuring we can modernize the power grid and make it smarter. So let's listen in. One of the reasons that I wanted to chat was a couple of reasons. First of all, I'm really fascinated by all the work that you're doing with predictive analytics as part of Buzz. And I also kind of wanted to talk about, you're doing, as far as I understand it, and please correct me if I'm wrong, with Buzz, with the energy grid, which is not traditionally seen as a particularly smart thing, or at least that's sort of the stereotype, but you're trying to almost smarten it with analytics, with drones, with things like that. Is that, which seems fascinating and vital, obviously, given kind of the importance of infrastructure. Is that right? Am I on the mark with that?
Yes, absolutely. And thank you so much for having me. I'm excited to be here and share more about Buzz. Yes, so the energy grid is interesting. It's aging quite quickly, and there are so many different factors and influences that are coming into play right now on the grids. One, we're seeing that climate effects are having a huge impact. We're seeing that aging grid infrastructure is having a huge impact. Renewables coming onto the grid, and also the electrification is all having major implications on the energy grid. And it's interesting with utilities. The process of inspections has been up to date, a very manual process being done with drones, helicopters, fixed wing aircrafts, and we're seeing so much data is being collected, but it's also been a very manual process to date as well. And so we're seeing that there's so much need in the automation process, really just to help these linemen, field technicians, and utility workers to make informed decisions so they can have a much faster time to analysis, time to maintenance, time to action, especially in really critical moments when they are facing bigger stressors on the grid.
Yeah, and that makes total sense. The climate change aspect of it is interesting too, just because it seems like, I'm out of New York, and so the infrastructure here
Mhm.
is fairly hardy. But friends of mine, when I talk to them, down in Texas and so on, you've got 3 or 4 day rolling blackouts, or kind of all these issues that occur that people are connecting to climate change. And it makes me think that in terms of everything you're doing with predictive analytics, between the climate change issues and the aging infrastructure issues and everything else, like the amount of variables pouring into any sort of predictive analytics package must be completely insane, for want of a better word. I'm just wondering, like, how do you sort of upsite, how do you bring something like that online and then make it mature and make it accurate? It just seems like, people have been trying to predict the weather for decades, and, impacts, and it just seems impossible.
Sure, absolutely. It's a great question. And I think in order to really talk more about the predictive side of things, it's really important to understand what is the current state of where we're at today. So, what's interesting is depending on, even to your point, depending on where you're located with geography, there are so many different issues that are impacting each region. Storms we're seeing is a huge one in the southeast and on the east coast, whether that's hurricanes or winter storms, whatever it may be, that are posing major threats to the grid. Here on the west coast, we see that high winds and really dry areas are also causing major problems as well when you have any sort of sparking issue. Of course, that's the major threat for a wildfire. And we see that it used to just be California, but now we see it more broadly across the West Coast. And it's interesting because up until recent years, utilities are doing these flybys of their infrastructure. Historically, they were doing it with helicopters with very highly zoomed out cameras, or they're walking the lines. And so they're walking the lines looking up with binoculars for any visual anomalies that they can see. But of course, that's a very slow process. And it's really hard to get a true understanding into the faults that are happening, or the physical anomalies on the structures that are happening, or to what areas pose a high risk. And so what happened about probably 5 to 7 years ago was this big transition to to drone collected data, and also then to high zoom, high resolution cameras collected, high zoom, high resolution cameras collecting up close imagery of transmission infrastructure, especially. And so when that process happened, utilities were collecting 5 to 10 times the data of what they were collecting historically. The challenge then that posed was the data it's being manually analyzed. So it takes an incredibly long time to analyze it. They're looking through every image, marking up the images to see where are the most critical faults, and then drafting inspection reports after the fact. That process takes months of manual analysis time, of course, at which point the data is outdated and you don't truly have an understanding into where the highest risks associated. So when we launched the company in 2017, and getting back to your question here, when we launched the company in 2017, we were hearing these conversations from utilities that said, we have all of this data that we're now starting to collect of the infrastructure, but by the time it's analyzed, we don't truly have an insight into exactly where the biggest faults are happening, or what areas pose the highest risk on our infrastructure. And so they needed a process to automate that analysis piece. And so that's where we ultimately started Buzz. That was the genesis of the company. And what became clear was, before we even get to predictive, we really need to provide a fast solution for identifying the highest risk areas, or the hotspot areas upon the infrastructure. Because if we're able to do that, then we're also able to help utilities know where they need to conduct more frequent inspections. When they've identified a hotspot, they can understand where they may have the biggest risk of wildfire, or the biggest risk of an outage. And so that's what we're doing with our solution. And then tracking all of this data over time, we're able to then predict trends of, okay, we've seen that historically this area has posed the highest risk, or we've seen that based off the patterns of failure in this particular area, that you may want to pay closer attention here because this area may have a higher risk of failure. And so that's where we see this industry going. We see that tracking these trends over time can take an industry which has historically been so reactive to all of these issues, to predictive and prescriptive in what's happening, so that they can preemptively provide maintenance solutions, or they can reduce the number of outages that occur in a particular area by making more of the pre-scheduled outages that they have to conduct maintenance.
I imagine that machine learning probably plays a big part in that, if I'm not mistaken, right? Just in terms of
Mhm.
designing models that will allow them to more accurately predict outages and things like that, or is that not, or is that still nascent, or is that kind of a mature area of it?
It's definitely a growing area. We see that, machine learning, computer vision are really at the forefront of that. And we see that over time, as we're able to collect more years of data, of consistent data of this infrastructure, that those algorithms can become even more accurate and can provide even greater insights to those utilities on a much faster basis as well.
Yeah. Yeah, no, that certainly makes sense. The other thing too that I thought was fascinating was the use of drones to check infrastructure and create data and feed it back and so on. Um, And when I've covered other industries, it's always seemed that it was an uphill battle to deploy and use drones in a fully effective way. There was either
Mhm.
regulations or technology issues, or, mostly this is kind of in a commerce context where people are trying to figure out how to deliver a package via drone in 15 minutes and failing because, of air rights and everything over cities.
Sure.
Um, in terms of this, though, in terms of using drones and UAVs and so on to inspect lines and feed data and all the rest of that, is that an environment where it's sort of been like they're relatively frictionless in terms of regulation? Is this something that companies are using more and more, or is it still something where there's kind of a back and forth? Because it seems like in other parts of the industry, other industries, it seems like drone is a back and forth thing.
Yes, actually, it's a great point. And it's something that has been a major challenge in the utility space as well, because when you're looking at transmission and distribution lines, these are tens of thousands of miles of line that a large utility, a large investor in utility is typically overseeing. And so regulations, especially the beyond visual line of sight regulation, or the BVLOS regulation, has been a really key driving factor. But what's interesting is we've been seeing so many more of these acceptances, or these waivers being granted in recent years. When you look back to 2018, there were only 12 BVLOS waivers that were granted in 2018, and then the same in 2019. But by the time you were at 2021, there were something like 43 BVLOS waivers that were granted. And then last year in 2022, there were 85 that were granted. And several of those that have received some of these BVLOS clearances have been large utilities. And so they're able to test much more of these long range inspections. And there's a great value of that. We see that it's a combination, I'd say, of challenges between the regulations, of course, which have limited the length or the distance that a drone can fly without the oversight of an operator, but also the battery life. The battery life is one that we are now seeing is continuing to increase in drones, or the ability to even piggyback drones off each other every so many miles. The combination of being able to deploy drones successfully at scale, I think, is dependent on the technology of, how great is the battery life, or how logistically can we stagger these drones, and then also the regulations. But I think we're starting to see and starting to get to a place now where it does seem feasible for drones to be able to take on some of these longer range inspections. It's not today, but I think we can definitely see it on the horizon as something that's possible. And in the kind of in the time between us, getting from where we are today until we're fully scaling these drone operations, we are seeing there's several other means of inspections which are really helping and aid that long range inspections, or kind of support those long range inspections as well. It's where some of these other long range aircraft are particularly valuable. We're also seeing things like ground based imagery, which is deployed on moving vehicles, which has also been pretty valuable as well.
Interesting. Is the infrastructure bill that was passed by the Biden administration, kind of all the federal money being devoted to infrastructure and the grid and so on, how is that impacting everything that you're doing?
I mean, we're very excited to see what's going to come of the infrastructure funds. The first concept papers, the submissions for those came out at the end of last year. And so we are really looking forward to the future of smart grid and ultimately grid resilience efforts that are going to come of this. Many utilities are heavily investing in grid modernization and grid resilience efforts, and those are at the forefront of some of the infrastructure bill fund applications. And so we're excited to see what's going to come of that. From our side of things, we look to be at the forefront of identifying where there's key areas and key needs for grid modernization. And the more that we're able to provide some of the insights into where utilities can upgrade their infrastructure to better modernize their grid and their assets, the more that unlocks potential for electrification and more renewables to come onto the grid as well. So we see that it's really the first step is talking about grid resilience, grid modernization, which will help us get to those even larger goals that we even see are a key part of the infrastructure bill.
Is it sort of a top-down thing where the feds are saying, we're going to give you this money, but we need like these specific things done in terms of renewal and upgrades and so on? Or is it more something where, for example, utility companies might be coming to data analytics firms and saying, tell us where we potentially need to modernize in order to deal with these outages or these issues or things like that? Or is it a combination of both? I'm just curious.
I think it's a combination of both. Sometimes we see that utilities know exactly where there needs to be key upgrades, or where they really need to modernize. And other times we're able to help utilities identify some locations where they didn't previously know they needed some additional modernization. I'd say a big part of it is with some utilities, they don't even know truly where their assets or where their components are deployed in the field. That could have been because the infrastructure or the information in their GIS systems may be outdated, or perhaps there was a wildfire or a storm, and so as a part of their upgrades to their infrastructure, they ended up relocating some of these assets. And a big part of our solution is we're able to help identify where there are key needs or where the asset is deployed first, and then where there's key needs for upgrading. And so I'd say it is a mix of both. It really depends on the utility and what investments they've already made so far to better understanding, one, their infrastructure, two, to collecting data around their infrastructure, and then three, how they've made sense of that data that's been collected.
Yeah, no, that makes a lot of sense. The other thing I was wondering, so I speak to a lot of school groups and people who are kind of figuring out how to make their way into the tech industry. They might have just graduated school, or they're just, looking for a career change or something like that. And a lot of them are really interested in analytics and predictive analytics and so on. And I was just wondering, I mean, what would your advice be for somebody who essentially wants to do what Buzz does, and analyze like which tools, which platforms, I mean, which kinds of disciplines, I mean, where do they start? Because it's such a huge, complex topic.
That is a really great question. It's interesting because I actually don't come from a technical background myself originally. I found myself really passionate about solving real world issues. And I particularly was motivated and inspired by the sustainability space, and then also about how technology could provide huge influence in more antiquated industries. And so that's what led me to exploring the world of really just AI in general. I was more interested in how we could use artificial intelligence to for good, really, and then to solve some of these critical issues. So I'd say that figuring out what industry you're most passionate about first is probably a great step, because AI, machine learning, computer vision can be data science can be applied to so many different spaces, and I think we're really just at the tip of the iceberg right now of understanding the applications for these types of technologies. And it's going to be exciting to see what the next 5 to 10 years bring in some of these spaces. But I would say understanding first what particular industry you're interested in learning more about, or what industry you want to apply some of these more technical skills towards. And then once you figure that out, find a problem that you're passionate about solving, because I think that that's been something that over the journey of the past 6 years that we've been with Buzz, that's motivated all of us, is having a problem that we're passionate about solving, and then a mission that we're really excited to get to work on every day. And so I'd say that that's probably the next thing that is most important. And then understanding where the real pain points are in that market with that problem, and figuring out a solution to help solve that, whether that's joining a corporation who's investing heavily in that type of R&D, or whether that's joining an existing startup that is tackling that problem or that space, or whether it's going out and starting your own. I'd say that as an early stage and as a young founder, for me, understanding that there were real pain points in the market and that we have a real solution that can ultimately tackle that space for some of the important driving factors for me to go out and become a co-founder of a startup. But I don't think that you can be too young to go out and tackle one of these spaces if you have a real understanding of the pain point, a real understanding of the problem in the market, and then a great solution that could help bring real value. So I think those are more overarching themes that would be helpful for anyone, whether it's someone early in their career, just starting out, or someone even looking for an internship, just trying to figure out more about, what particular industry they're interested in entering.
When you were starting out and when Buzz was founded to that point, did you find that in terms of going to potential clients and so on and talking about the pain points and everything and using analytics and AI to solve these issues, did people buy in easily to it, or was it something where you kind of had to explain the wonders of AI and machine learning to like really get them to get it?
Interestingly, I think most people, so, when we started Buzz, it was a company that really came from a need in the market. And so most people understood the outcome they were trying to achieve. And that outcome was with the use of machine learning and computer vision algorithms. We're in a space that really hasn't had the same experience with artificial intelligence, machine learning, computer vision. Those are very new concepts in the industry that we're in, but I think many individuals understood the outcome that they were hoping to achieve, of a faster time to analyzing this data with some sort of artificial intelligence. And so I think where we spend a lot of our time, even today, definitely starting out and throughout this journey, but even today, we spend a lot of time on the education piece, on educating those who are our customers or those who are partners in the space on what are the strengths that AI can bring to the table today? What are its strengths 3 weeks from now, 6 months from now, a year, 5 years from now? And what is the trajectory of where it can go? And then also, what are its weaknesses today? What are the gaps that we currently have in AI, and what are we doing to mitigate those weaknesses or those risks associated with it, and how do those weaknesses diminish over time? I think the value of our solution, of course, is that it continues to learn and grow, and it grows very quickly on very small amounts of data. And so that's where we spend a lot of our time on the education piece. And I think it's interesting because we are starting to see now more utilities bring in data science teams. We're seeing them bring in software engineers, machine learning, computer vision engineers to help bring support to these types of issues. And so it is exciting to have conversations with those in-house teams as well to figure out, okay, what are their biggest pain points that they have today? What experiments have they tried? Where can our solution plug in to bring value on day one, or even 6 months and a year from now? So depends on the utility. We've seen a lot of growth in the past 6 years, and we're looking forward to seeing how that progresses here in the near future.
So in general, the education's gone easier. I mean, in terms of
Yes.
oh, that's good. I mean, there's
Yeah.
so much confusion and hype, it seems like, where, it seems when you talk to people, some of them are unsure of the capabilities and what's real and what's, 5 years from
hmm
now real. Yeah.
I think that's been a big part of our, mission at Buzz, and a part of our even our sales process is we want to be as honest and transparent as possible. We're a big advocate actually of someone running a live demo of our AI. So we've done several times tests where we have the team provide us, let's say, 200 images and 30 minutes to analyze that data. And we'll sit there and provide basically the real time results. Once we're able to process that information, we'll sit there with the utility team and show, okay, here's where the AI performed really well. Here is where it did not perform as well. And here's what would happen with more data, with more retraining for how we could improve on those weaknesses. And we are definitely big advocates for that type of transparency, because to your point, there are so many misconceptions, or there's also a lot of lack of understanding about AI, that it's not 100% perfect. It's not a system that can show up on day one and perform with 100% accuracy. But given the right data sets, its ability to learn can become a really valuable asset very quickly to teams. And so that is a big part of um, our, I guess, value proposition, is that we can show up with these pre-trained algorithms that can perform with very high accuracy, but then very quickly it can learn and continue to improve.
I assume that the training speed has become exponential, right? Versus when you started Buzz, in terms of just general speed of processing, or is it more? I mean, in terms of the evolution, has it been more kind of like a hockey stick, or is it just more of a kind of a gradual
hmm
rise?
I mean, we can process the data very quickly with higher compute power, and we're working with imagery, so we are able to process that data very quickly. We've seen that depending on what a utility's requirements are, we're able to process the data well within the means of what's necessary for them. So I don't know that we've seen that the processing power that we've needed has gotten so much faster, because we're already performing with the highest speed the utility needs. But I think depending on what industry you're in, that definitely has more relevance.
Yeah, no, that makes sense. Well, I mean, and what's the end state for the utilities you work with? Like, what, I mean, in their sort of ideal world, like, what does the grid look like? I mean, I'm assuming some sort of highly reactive, extremely smart, for want of a better term. But I mean, for people who aren't really sure how the grid operates, like, kind of what's the idealized form? Like, what is it?
I think there are many clear goals, and several places where um, there's a lot happening on the grid. For example, the rise of electric vehicles is a big mission for utilities. I think a definition of success is if we're able to successfully onboard electric vehicles, and we're able to reach this level of electrification that we're all hoping for, in addition to the ability to onboard all of these renewable energy resources, as well as phase out some of the um, coal and things like that. If we're able to do that successfully, and we're able to keep the power on, basically reducing downtime for these customers, not only here on the West Coast, really, as we're seeing across the U.S. I think that's definitely a definition of success. And if we're looking at this grid of the future, we're now seeing that utilities are getting access to so much more data. They're unlocking data in various aspects of the entity, whether it's on the inspection side, whether it's for their customers, whether it's on the generation side, there's data coming at them from all these different angles. And historically, what we've seen is the utility industry has been very siloed, where each kind of unit within a utility operates almost as its own business. And I think now what we're seeing is all of these different data sources and all these different data sets coming into the play and coming into the forefront are creating this real need for a way to make sense of this information and turn it into actionable insights, but then understand how each of these data sets can, and if they can, relate together, ultimately to give a utility a much better understanding of where they're at today, of the health of their assets, to balance the load that's coming in. So that's where we see there's a great potential in this market, and we're only again scratching the surface of it as well. And so I think as we're looking to achieve some of these really lofty goals that we have here coming up pretty soon on electrification and also on renewables, some of the biggest things that we need in order to achieve success in those departments are understanding how we can turn all of these various types of data sources into actionable insights, and then also how we can mesh all of these different types of pieces of information together to create a true holistic understanding of where the utility is at today.
Yeah. It's interesting because near where I live, there's a huge natural gas electrical generation plant that provides something like a quarter of New York City's power, and they're actually taking it offline for wind turbines. They'll be offshore, but they're going to keep the facility because the energy generation from the turbines is going to still run through the old facility before going into the grid.
Mm-hmm.
And a lot of people in the neighborhood are freaking out because there's this erroneous assumption that wind power isn't going to be able to provide the same amount of energy as kind of the old infrastructure. But I keep telling them that they wouldn't be making this sort of investment in this infrastructure without data if they hadn't sort of used predictive analytics to frame this out, that utilities are not the kind of companies that would necessarily do this kind of thing off the cuff.
Yes.
So it's just fascinating to me that, people who are connected to the grid don't see all the decisions and the analytics and the data and the machine learning and so on that go into this, but it does keep everything running. It's really amazing.
Yes. Yeah, it's a really great point. We see that so many of these different, types of renewable generation are going to unlock huge capacity and huge opportunity for, better uptime even, and reduced downtime, reduced outages, things like that. So, depending on where you are, of course, those generation sources look different, and there's multiple combinations of generation that are coming into the fold. But predictive analytics is a key piece of that, of understanding, how we're able to unlock greater capacity, and then also understanding as well how we're able to store that energy. The ability for us to store it in a longer term way will be really critical for us achieving success in that transition to more renewable based energy generation.
And that's it, folks. It's always fascinating to see how technologies like predictive analytics can not only be used to tackle intense real-world problems, but also to update the aging, often antiquated systems that we depend on for so many things. As Kaitlyn said during our chat, it's going to be fascinating to see what happens over the next 5 to 10 years as these technologies mature and end up applied to different industries. Here are some other quick takeaways from our talk. First, if you're interested in launching a startup, take the time to identify the pain points in the market and whether your idea is a real solution that can solve that pain. Second, it's still very early days for artificial intelligence and machine learning. If you're in a business where you're dealing with people who are unfamiliar with AI and its potential, take the time to educate them on how it works. By walking them through the strengths and weaknesses of the technology, you'll get them on board with your plans for using it. Third, whatever your industry, a real key to success is effectively analyzing data. Without analytics, you'll have a harder time achieving tactical and strategic goals, especially over the long term. And that's it, folks. Thank you for joining us. And remember, DICE is your best resource to find the tech talent you need to fill your open roles, and for technologists, the best place to grow your tech career.